All right, let's take a look here. And, you know, the purpose of this is not for me to say these are all things you should be able to do day one, right? This is why I said that earlier. It was a little evil to give this to you before you had a chance to remember anything. It's just there's a few things on here I want to make sure you're aware of. There's a few things on here that I want to make sure aren't completely foreign to you. Maybe you just forgot, which is different than never done it before. So don't feel completely bad if you weren't able to do some of this. Like a little bad. But not completely bad. So very bad is going to be number 3. So this first one, if any of you guys are wondering, you know, okay, so warm-ups for Diffie-Q is a Diffie-Q. That's a little evil, but you've seen problems like this in homework. Hopefully, I mean, this is a problem you could do. I could give my Math 88 students, when I teach them equations, a really difficult equation they could never solve just to check the answer. Okay, they could do that. This is just checking answers. So I know what y is, so I know what the hell to put there. Right? In fact, before we even do this, you notice how y equals 3. Does that solve the equation?
Yes.
If y is 3, y prime is 0. Y double prime is 0. So you get 2 times 3 is 6. Yes. Isn't that neat? Can you get 3 from that solution for a value of x? Can you get 3? No. Okay. So that's interesting, right? By itself, that's interesting. So that's going to come up in the class later. All right. So just the one I gave you. Don't worry. Everything I just said was side notes. This has nothing to do with the problem. Now let's do the problem. I know what y is. Now I need to know what y prime is. Well, y double prime. Y prime, of course, is just what?
Negative 2x e to the negative x.
Yeah, it's good, just the good old chain rule, right? E to the negative squared itself times the derivative of the upside of the inside function. But now that sets up my y double prime is going to involve good old product rule, right? So the first product rule is easy. Derivative of x, sweet. Plus, actually, you know, plus the derivative of this guy, which is this, right? In a sense, so it's going to be plus negative 2x times negative 2x e to the negative x squared. Is that cool? So then you get y double prime is negative 2e negative x squared plus 4x squared e negative x squared. So now you can, oh sorry. Yes?
You can always just substitute that in the beginning, right?
Now that I've got all the parts that the equation needs defined, now I can throw them all back in.
Well, instead of even messing with the e to the negative x squared, you just make it like y minus.
Oh yeah, along the way, you could replace it with what y is, but you don't have the plus 3 there anymore. So you really have to replace it with y minus 3 to make it official. Sure, okay. Of course, there's always more than one way to do something, but this is the most just direct. Let me define all the parts of the equation so I can throw them all in there. I like it. So y double prime, 2x times y prime is just going to be negative 4x squared e negative x squared. Is that cool? So when you do y double prime plus 2xy prime, these cancel. You guys with me? Now it's just plug and chug. Now it should be relatively simple. So all I have left is negative 2e negative x squared plus twice y, and twice y is going to be 2e negative x squared plus 6 equals 6. And sure enough, those two cancel, so you're just left with 6 equals 6. Check. I like it. So that part, it's not. You can do it. You can solve. You can check a solution to differential equation before you learn differential equations. Of course you can. And hopefully most of you have done that kind of thing before. Okay. I was a little concerned with how much trouble was being done on part A, but secant squared comes from what? Secant squared is whose derivative? Tangent. So cosecant squared is negative, because remember the cos stuff is always the negative. I like it. So that so far we got it. So far it's negative So this integral is negative to a tangent theta. And of course, when you integrate negative sine theta, you get positive cosine theta plus c. I like it. Shouldn't be a big deal. It's a beautiful thing about co stuff. You just memorize the non-co stuff, and then you just make the co stuff negative. This one is a little obscure, but it's got the same idea. Let's do this part first. Now watch. This is definitely going to be 3 ln of 2x minus 1, except for one thing. I mean, it's got to be ln of 2x minus 1. It's linear. ln's derivative is 1 over the thing inside, right? But it would, if I do the derivative, it's going to have an extra factor of 2 because of the chain rule, so I just divide by freaking 2. So I kill that extra factor of 2. You don't always need u sub, especially if it's linear stuff that's inside. Don't do u sub. Well, you can do it, whatever. But you shouldn't have to. So it's still negative. And who remembers the derivative of 7 to the x? Oh shit. All right, what's the derivative of e to the x? E to the x times natural log of e. And natural log of e is 1. All right, that's why it's the only one who the ln piece doesn't show up for. So the derivative, I know we're doing an integral.
A to the x, natural log.
Natural log of a, I love it. So if you integrate it, it's not going to be times ln a, it's going to be divided by it to kill the thing that would come out. So the derivative of, so the answer can't be 7 to the x. So that's not a bad place to start. And you just tell yourself, all right, self, I ain't done yet. I know my plus c is, so I ain't done yet, so don't yell at me. If I did this guy's derivative, though, is it what I had originally? No, it's got an extra factor of ln 7, so let me divide by ln 7 to kill that. Do you guys follow what I'm saying? I don't know if anybody's ever told you to think about it that way. Too many people do u all the damn time, and then solve for dx, which is bullshit. Sorry if you love doing that. I really am. But what that does is, people can always solve for dx, but it doesn't mean that your u sub was correct. And then people just kind of force it to work to match up with what they got. That's bad. That's bad. That's just bad. So over here I need to still kill the ln 7 that would want to come out of that derivative. And of course then I need a plus c to cover my ass and make teachers stop yelling. How's that? Is that all right? Okay. I love part C. I really, really do. Did somebody think they got that done?
I mean,
Yeah, I helped you out a little bit. Anybody have a method they use to solve that, or did you try something and you weren't sure how the hell to make it work? I mean, what sucks about that problem? If only the inside x was freaking x squared, then it would be beautiful. Then it would be obviously u sub. This is less obvious u sub.
Yeah, we use them for x minus 1.
Okay, cool. I like it. So u is x minus 1. Oh, let me get a fresh sheet down. U is x minus 1. So du is dx. So far, so good. And then what you do from there?
Plus 1 times u.
Oh yeah, exactly. So since u is x minus 1, so you both are good, x must be u plus 1. So now, and this is the flexibility in u sub that I don't think enough teachers teach when they teach you u sub. There's more flexibility. It really is just a substitution. It almost, as long as you do everything legal, as long as you make all the x's become functions of u, and everything's legal that you did, it doesn't matter how the hell you got there. So once you define u relationship to x, you should be able to solve for x. It doesn't always work, but this is definitely one where it does work. And notice what the problem is. If only the stupid x minus 1 would have been on the outside in the first place, I wouldn't have to do any of this shit. Right? That would have been x to the 1/2. I would have distributed it through x minus. So what is this doing then? Shifting it so that the inside is a single term. So then I can distribute the damn thing. That's all this. This is just going, oh, you guys wrote this wrong. Let me shift your system so the interval is easier to do. Okay. So then you get integral 1 to 2. That's my own thing. I just put parentheses around it because that's not related to you. If you guys want to change limits, whatever the hell, I don't care. X is u plus 1. And now I get square root of u, right? that cool? I like it. And then you distribute the u to the 1/2. So you get u to the 3/2 plus u to the 1/2. And when you integrate that, what do you get?
3/2.
Well, careful. What do you get now? Integrate. U to the 3 plus 2 is 5/2 with a 2/5. 1 plus 2 is 3/2 with a 2/3. Have you ever shown you that trick? It's a beautiful thing, integrating variables to a fractional power. When you're integrating, you just add the damn things, of course, because you're going to add 1. LCD would be a 2, so you're really going to end up adding 2 and 3. Well, there's 2 and 3 already. 2 plus 3 is 5 over 2, and the front's going to be reciprocal, of course. You guys still with me? If you got a different way you do it that makes more sense, then do it that way. I don't care. As long as it works. Where am I at? Plus C. This is going to be, no, get out of the plus C. And then it's going to be from 1 to 2 for x. So when x is 2, 2 minus 1 is 1. So this would be, this ends up being like 2/5 plus 2/3, right?
Yeah.
I like it.
16, 15.
Yeah, 6, 10, 16, 15. Kicking the ass in. I like it. And hopefully you guys all know how to check that on your graphing calculator. Do you know how to integrate it in your graphing calculator? Yes? You can. It's kind of nifty because it actually just shades in the area if you've never seen that. Has anybody never seen that? Has anybody never seen that? Don't feel bad if you've never seen it. So if you put in here, let's see if this will show up. I'll find a good spot. No, get out of the graph. Got it. Clear, y equals clear. Oh, I'm in freaky stuff. Mode, function, y. Oh. So what do we got? X.
Like a Spanish calculator?
What's up?
A Spanish calculator?
Apparently, right now it's in Spanish. This is when you have kids. My girlfriend has kids, so their tablets ran out of power, and then I was like, all right, look at this. You guys play with this for a second. Somehow they do the most interesting thing. So I didn't even notice that until you said that they somehow changed it to Spanish. I love that stuff. So let's hope that doesn't really mess us up. Times the square root of, where'd it go? X minus 1, right? That's the thing. And then if I zoom, look at that. That's awesome. Zoom 6. Ooh, dimension error. Stat plot's probably on. Let me deactivate that. All right, that's better. So there's the graph of the function. Can you guys see that all right? Somewhat? Can you pretend like there's a graph up there? Okay. And now if I go to second calc, there's my integral. And I want to go from 1 to 2. I get 1.0666801 if you do 16 divided by 15. 1.066, you see that? 16 divided by 15. 1.066. All right, I like it. So if you didn't know that, that's kind of crazy. But now you do. Okay. Spanish. All right. It's not Mandarin or something. I don't know Mandarin at all. I know some Spanish. So what about these guys? These should have been real quick. So what is this really? This is going to be 1 over sine. What quadrant am I in? Yeah, so sine is going to be positive. The reference angle is pi over 6. What's sine of pi over 6?
1/2.
Yeah, 1/2. So it'll be 1 over 1/2. That'd be 2. I like it. And I have no idea how you got the sine and cosine and all that stuff memorized. But to me, for example, I hate SOHCAHTOA. We need to stop teaching SOHCAHTOA. If you love SOHCAHTOA, I'm sorry. But if you just taught from the beginning that cosine likes x and sine likes y, so many things make so much more sense. Right? Cosine starts off at 1 because it loves the x-axis. So at 0 degrees, it's all the x-axis. There's no y piece for the poor little sine dude. And then here's a really neat thing. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Okay. And then, of course, all the negative shit and all that kind of stuff. cosine, so this is going to be negative 2 pi over 3. It's going to be in what quadrant? Fourth quadrant. And it's going to be, so cosine's going to be, so if it's in the, yeah, it's going to be positive. So I can take the negative out without any problem. And the reference angle, and 2 pi over 3, let's be careful. What do you guys say? So 2 pi over 3, here is 3 pi over 3 would be there, right? So 2 pi over 3, of course, is how many degrees? 120. So where should I be? All right, let's try it again. So negative 2 pi over 3. How far away from pi is that?
1/3.
So if I go negative pi, that's all the way back here. I'm 1/3 away from a full pi. So I should be in the third quadrant, right? You guys with me?
Yeah.
Okay, good. I don't know, some of you guys are like, you're just staying quiet because you thought you were wrong, but I was like, wait a minute, this is not correct. So this will be, so the cosine should be negative. So it should be negative cosine pi over 3. I don't know if that's how you guys did those problems. I always thought about the quadrant, got the negative, and then just put the reference angle in. Bam. What's cosine of pi over 3? So here I would say it's close to the y-axis. Cosine likes x, right? Pi over 3 is 60 degrees. So it's going to be squared. It's going to be 1/2. It's not going to be square root of 3 over 2. It's going to be 1/2. Is that at all? No? Okay, so negative 1/2. What about this one? This is one you might not have seen for a long time, but unless you took my 281 last semester. We did this the first time. What the hell does this mean?
It's the arc sine.
Arc sine, good. What is that physically? Physically.
Isn't
What
it
is
the
it?
outer
Is it a
side?
line? Is it a plane? Is it a number?
It's a
It's an angle. I love it. So it's the angle whose sine is 5 over 13. So I can draw the representative triangle, even if it physically doesn't make sense. It's just a representative triangle. It's not an actual physical triangle. So if the sine of this angle is 5 over 13, where's the 5? Where's the 13? Sine likes y. So there's the 5, there's the 13. 3, 4, 5 triangles exist. 5 blank 13. 12. So it's good to know a few Pythagorean triples. 5, 12, 13. So then the tangent of the angle would have to be 5, 12. I like it. And then this guy just kills me. If anybody wrote 2x minus 4, I have serious reservations about it. Now, if you did that because your brain just sort of shut off for a minute and the little part of your brain changed, went, that sounds good. But if you actually believe the answer is 2x minus 4, that is a major problem. The only thing you can do with this problem really is factor out 4. Square root of 4 is 2. So when you take a 4 out, you get x squared minus 4, and that is all you can do. That is it. But that's such a huge problem. If you actually believe it, it makes a lot of problems so much easier. So you get to the wrong answer much quicker. I don't know if that makes you feel better, but it's important. It is. It's more important to save time than to get the right answer. All right. And then semi-quickly here, when you factor this, you get x is a factor, and you get a repeated factor of x minus 4. This is one of my favorite things, and I know I'm the weirdest person in here, but just because it's sort of like covering your ass for everything that could have happened. If you have something you didn't need, you'll solve like b is 0 or something if you didn't actually need it. But if you don't put it here, you haven't covered your ass that it might be there. All right, I just love that idea. Who remembers where to go from there? You guys are like, I didn't remember that stuff, John.
Common denominator.
Yeah, multiply both sides by the denominator. You've basically created an equation. So if you multiply both sides by the denominator, the a picks up the x minus 4 squared, the b picks up an x and an x minus 4. Is that cool? The way I'm saying that? X will cancel, it picks up the other things. X minus 4 cancel, it picks up the other things. Both x minus 4 cancel, so that c picks up the other thing. By the way, partial fractions, I'm not just doing this just to torture you. That's just part of it. But also, it'll show up this semester. Now, I don't know if you guys... Now, you could foil this and bring the A through and bullshit and do the coefficients stuff, but it's so much better if x is what's a good value for x?
0.
0. If x is 0, don't I lose 2 terms? And why am I allowed to do that? Because x can be whatever the shit I want it to be. Right? So if x is 0, I get 32 equals 16a. So a is 2. You guys see that? Is that cool? You guys see that? Okay. Even if you've never seen that before, it should make sense. Nothing wrong with foiling, distributing, equating coefficients. I love the idea of equating coefficients, unless there's a better way to do it. So what's another good value for x?
1.
No.
4.
4. So if x is 4, what's left alive? Yeah, so I get 4c equals, well, you get, if x is 4, oh shit, well, you get 80 minus, that'll be negative 12, that'll be 20, I think. Let's just pretend like that's right. C is 5. And then how do I get what b is? Yeah, now I can pull out a single system, like a system of equations. So I know that ax squared plus bx squared has to be 5x squared. Well, a is 2. Are you guys cool with that? You get an ax squared, you get a bx squared. That's your only x squares. So a plus b must be 5. So 2 plus b is 5, so b is 3. And then you can plop those over the right stuff and be done. I love it. I love partial fractions, and I know you're all like, you would. But it's just such a thing you can sink your teeth into. Right? Okay? So any lingering questions about anything from those? And again, if you had a lot of trouble with any of these, it doesn't immediately mean you're in the wrong place or something. It just means maybe you should go review it. A problem like this, though, it's really easy for teachers just to not even assign anything like this and never tell you about it. So that sometimes happens. Okay. All right. So I just want to do, let's see. Oh, wow. Just very quickly a few things. Just to get into stuff here. Oh, so let me do this. This is kind of neat. Maybe I should just stay on this thing here. So, to get away from review, to get to new stuff, if I write this equation here, let me just let you think about what that might mean. Think about it for just a few moments and try to see if you can't be able to tell me something about the function that would be involved in this equation, or a way to interpret this equation. I mean, what is y prime in general? It's a derivative, which is also physically, geometrically, the slope of the function's graph, right? So this is saying that the slope of the function's graph everywhere is twice the y value of the function. That's kind of interesting, right? That's a way to interpret this equation. So you can try to interpret any equation geometrically, right? Is it always useful to do that? No. But it's one thing you can try to do. Anybody see a very easy answer for this? Yeah, okay, well, if y is x squared, you got to be careful. What's y prime? Oh, no. So the solution, yeah, see, and then the integral is going to have x cubed. It's going to be crazy. But I mean, there's nothing wrong with that. It's beautiful to come with an idea, see why it's wrong, understand why it's wrong, and then move on. It's beautiful. Whose derivative is directly related? So another way, a more fundamental way to interpret this is the derivative of the function is twice what the function was to begin with. What's really the only function we know of that acts like that? Whose derivative is directly related to itself? E. And of course, the 2 would have come from where? Yeah, the exponent, right? So this would be e to the...
X squared.
Nope, careful, you're overthinking it. E to the 2x. You can see how that does work, right? Y equals e to the 2x plus c, of course. Now What would C have to be here, though, to make this work? Because this is sort of like related to the problem, the very first problem, but notice if I put it in the same form, it's equal to 0. That first problem is equal to 6. And then it did have a constant value that wasn't 0, right? Okay, so I get y equals e to the 2x is an answer to this. How did we solve it? You guys don't even know how to solve any diffie-qs yet. We solved that one because it's a relatively simple equation, and you just have to have the right way to look at it. Am I saying it's always going to work? Hell no, right? But there are very simple things you can realize about this. And one of the first ones that when I took diffie-q, my instructor didn't say this until way later. I'm like, why didn't you say that on the first damn day? That just says whose derivative is directly related to itself. Right? There's a factor of 2 there, but who gives a shit? That's just a chain rule thing, right? All right, maybe. Now, a simpler solution is y equal, I don't think I didn't say this yet, y equals 0. Because then if y equals 0, y prime is 0. There you go. Right? So this is the derivative of a function is everywhere twice the value of the function. Well, the freaking value of the function is always 0. It's what we call a trivial solution. You made everything 0. That's amazing. That's the trivial solution. Good job. The other one is a little more interesting solution. Do you guys get what's going on? Okay. What about, let me see. Let's come up with a couple of funky things. Oh, now watch this. Let's do this from the other direction. Start with y equal cosine x. What's y prime? And so y double prime? Negative cosine. So can you create your own differential equation? Sure, of course you can. So any the simplest one would be like y double prime plus y equals 0. Now notice that this one I did specifically for a reason. Notice this one has a minus and this one has a plus, right? But this one, of course, is related to its first derivative. I should have went second derivative, but too bad. E to the negative power is going to change sign how often? If it's a linear coefficient. So e to the negative ax. The first derivative, it's negative. The second derivative, it's cosine sine is kind of weird, right? This one is if they start off positive, maybe they'll become negative, and then they stay negative, and then they become positive, and then they stay positive, and then they become negative, and then it stays negative. So it's a little bit stranger relationship then between the derivatives. You guys start to see. So I'm just trying to lay the groundwork of how you're going to have to look at the problems to be able to work them out well, right? So one way to look at differential equations is it's a bunch of learning forms of equations and then understanding what method to use based on the form it's in. That is the less interesting way to go through it. And that's the way that you will forget very soon after the course is done, right? If you analyze the equation more in more than one way, right? And try to make sense of why does the method that we use work. Do you understand the derivation of why the method works? Get a little deeper into it. That's the better way to go. What was the... Oh, you didn't write that down there. Too bad for you. So, I got like no time left over. What time we go to? 6:45? Which is like what time it is now? All right. So, obviously, next time we will focus, and just to warn you guys, the first section especially is going to be a lot of just terminology. It's not going to be any real methods yet. Right? In fact, most of the first chapter aren't really any methods yet. It's terminology and identifying types of things, which is really good. It's laying the groundwork, but it's not going to be the most exciting thing in the world. If you haven't gotten your book yet and you want copies of the homework so you can get started, you can always come by my office. I can do that for you. All right? Okay, cool. Yeah.
What is the purpose of differential equations? Besides finding a correlation, is there a specific reason in which it helps?
So, what's the purpose of equations? So I can start there, right? It's